Hello, good afternoon, good morning, good evening. This is the Coding Train with me, Daniel. Oh, I said Daniel. Sometimes I say Dan, sometimes I say Daniel. Every once in a while somebody calls me Danny, which I always kind of enjoy, although that's never really been my name. It's a Thursday afternoon. It is May, right? May 25th. It's around 4:20 p.m. Eastern Time. I am live from New York City on the Coding Train. And this is a semi-weekly, sometimes whenever I have some time, show, thing, stream, internet, television, education, space type thing where I do some coding tutorials and coding challenges and answer questions and a variety of other things that I end up feeling like doing while broadcasting live on YouTube. So welcome, thank you for tuning in. I am playing some lovely music by the great Adam Blau in the background. I think I will fade it out now. As you know, I enjoy having music sometimes in the background, so if you have any suggestions or things that you're working on that you want to send my way, please do. Okay, so what's going to happen today? Looks like everybody is here, and I'm not seeing any complaints about sound or visuals. So I am going to return today to my machine learning. I'm trying to avoid using the word syllabus. I feel like syllabus and YouTube do not go together. Let me try a different word. I'm going to return to my machine learning list. Syllabus would actually work quite well. S-I-L-L-Y-B-U-S. My machine learning syllabus. Let me figure out where I left off. This course long ended many weeks ago, but I'm still trying to make video materials for it. And I think I'm here in week 3. So the topic that I have for today is linear regression. For those of you who are watching this late at night, perhaps you're curled up with some candlelight and some herbal tea and you have a nice book beside you and you're playing some soothing classical music, this will also put you to sleep, almost definitely. What I want to do today is look at everything that I'm doing is leading up to building a neural network program from scratch in JavaScript and in processing, which is Java, one of these environments. And so I have some steps along the way that I want to do. So previously, I looked at just kind of an overview of what machine learning is. We looked at the k-nearest neighbor algorithm and how to do a similarity score between two data points. And today I want to look at this idea of I have a data set and I want to fit a model. What does it mean to fit a model to the data set? For us, for today, that model is going to be a straight line, and we're going to be able to calculate that model, calculate where we should draw that straight line with maths. Yes, I'm an American who likes to say maths. I don't know if that makes me pretentious or the opposite of pretentious, but that's just who I am. Emra in the chat asks, why JavaScript for a neural network? I don't have a good reason for that. In fact, it's a terrible idea to program a neural network in JavaScript. But I'm going to do that anyway because I like to run demos in the browser and kind of get my hands in the code, and JavaScript is a language that I am kind of working with. I will, however, I do intend to do some tutorials as we dig down further. If I keep going on my syllabus, that eventually I'm going to start looking at something called TensorFlow and something called Keras, and those will require us to spin up some Python code that I will then talk to from JavaScript. And actually, I guess my reason is one of the things that I'm trying to do is always have a visual, animated or interactive component to what it is that I'm building, and that's just a sort of arbitrary constraint that I give myself in the hopes that people will take that and make all sorts of more creative and beautiful and interesting things from it. Okay. Okay, sing the audio. By the way, I get this a lot. My audio is out of sync. So for whatever reason, I think when the audio is out of sync, it's not me, it's you, or it is me. I'm trying to throw my voice in a way that I could maybe make the Audio, I can't do it. Audio out of sync. And I hear that if you refresh the page, sometimes that fixes it. The good news is I am recording everything I'm doing to disk, and everything that I do today will be published separately as individual video tutorial chunks. Okay, so the coding train is brought to you by... Wait a sec, do I have? It's not brought to you by anything. It's brought to you by me, but it is here with the support of the patrons. So I would like to start by saying a thank you to the patrons of the Coding Train. If you would like to join the patron program, you can go to patreon.com/codingtrain, and you can pledge, and with a pledge comes membership to a Slack channel and other rewards. Sometimes I'll send you a book, or I'm making t-shirts and things like that. You can also support the Coding Train by going to codingtrain.storenvy.com if you would like to buy some Coding Train merchandise. Okay, got those things out of the way. Now, typically, even though there's no typically because I'm kind of all over the place, I like to do these live streams on Fridays. I like to have opening segments where I share work from the community or I answer some questions that were posted on Reddit. I'm not prepared for any of that stuff today, so I think I'm just going to launch right into the material and start talking it through and making examples. But if I'm hoping that perhaps I will be back tomorrow on Friday at some point for a kind of regular Coding Train episode where maybe I'll be able to do some sharing of work from the community and answering some questions. Okay, so Rick Van de Broek in the chat asks, why won't you make more native JavaScript tutorials without P5.js? I have been getting this question a lot. I'm trying to think. I need something to help me think. Can I have some meditation music? This is actually my new debugging music. I'm debugging. I'm trying to breathe deeply, to think about why is it that I don't make vanilla JavaScript tutorials without P5.js. I don't have a good answer to that question. I think there's a lot of value in writing code without libraries and dependencies. I think there's a lot of value in writing code with libraries and dependencies. And I am not opposed to doing tutorials in JavaScript without P5.js. And I do periodically do stuff with Node, server-side programming in JavaScript using just plain old Node and some Node packages as well. I suppose the answer I have to that question is that P5.js, as part of the Processing Foundation, is a project that I'm just personally invested in. It's a project. It's open source. It's a piece of open source software that I care about, that I think is bringing good things to the world, and I would like to support it and explore it and teach with it. I find it nice to be able to skip past some of the gobbledygook that is native JavaScript and be able to, in a more succinct way, draw and animate. And P5.js, I believe, is a good platform for that. But there are areas where P5.js does not have certain functionality, and I am not opposed to at some point looking at doing tutorials with native JavaScript. A better question might be, why aren't you programming using ES6 syntax? And then maybe you're thinking to yourself, what is ES6 syntax? And I think I've talked about this before. This is something that I need to come to grips with. I'm looking at something ominous. Why don't I program with ES6? I think I need to. I think it's time. I think it's what people are using. I think it's already 3 years old. There's some parts of it that make me somewhat uncomfortable, like the fact that there's an equal sign and a greater than, and that means function, and there's some kind of stuff. But I do think in particular that the class syntax for doing object-oriented programming matches classical object-oriented programming languages. It makes more sense. It's a little less awkward. I would like to start doing that, and I am thinking about this fall starting over and doing all of my beginner learn to program from scratch in JavaScript tutorials using ES6 syntax, possibly with P5.js. this might be a great idea. It might be a terrible idea. I look forward to hearing your feedback. But today, I will be still using my old ES5 syntax. If only you could throw internet tomatoes at me. That would maybe I can build up some sort of like Node.js socket-connected catapult system by which you could be watching the live stream and pressing a button and tomatoes could be flung at me. Or candy. Popcorn. No, popcorn's not good. I don't know. Flowers, something, or tomatoes, whatever. Okay. What's happening now? I'm looking at the chat. Okay. Let's see here. I see some tomato emojis in the chat. Wonderful. Okay. If you didn't see today, I released a compilation video of, I'm just going to, oh, look at this, I'm live. I encourage you to check out this video from ITP's 2017 spring show. I did a live stream where I interviewed students, showed their projects. ITP is the graduate program here at New York University where I teach full time. And if you want to check out what students are doing here, check out this video. Here, I'm like promoting my own videos in my video, which is a little bit of a problem. I did most recently a Minesweeper coding challenge. That was quite a bit of fun. If you have made a variation of Minesweeper, you should go to, because maybe I can show some of these tomorrow or next week, depending on when I come back next. If you go to Rainbow Code, under Coding Challenges, and then if I scroll down here all the way to the bottom to Minesweeper, there is a README here. Oh, look, there's already some. So let's look at, this is, oh, I can't see. This is just a repository, so I don't have a demo. And this is just ported to TypeScript. So let's look at this one right here. Oh, Canvas. Let's look at this. And we have, look at this. Ooh, I love it. So some color, some new interface stuff, ability to change the width and height, a timer, a new game button. And by the way, one thing I really missed in my Minesweeper coding challenge, which I'm so sad about, was that the way that Minesweeper works is it's designed in such a way that you can never by accident click on a bomb as your first click. And I made this bee sweeper, click on a bee to get stung. And the way that that's done is you click on a cell and then all the bees are placed. And the part where you click is not included as a possibility. So I should have done that there. Okay, so I think now we are ready to start getting into linear regression. Or linear regression. Yeah. All right, so what do I want to do here? Let's put on Symfony 40. And let's get set up here. So I need to... Okay, so let's think about this. Okay, Minesweeper will work. Let's put this, oh no, session 3, that's where we are. I'm in session 3. And I'm going to grab this similarity score, and we're going to say linear regression. And we're going to get rid of movies.json. We're going to open up the Atom text editor. Tom in the chat makes an excellent point, which is this whole class thing in ES6 is just syntactic. This is very hard to say. Syntactic sugar. By the way, that would be a good name for a song. Syntactic sugar. There's a wonderful discussion going on. Okay, I gotta not look at the discussion. It's sometimes very distracting. Okay, so now what I need to do is open this up in the Atom editor. Don't know why this always runs. Ooh, okay. See what happens here. Okay. All right, so now I have some code running. I need to run a server. And I'm going to go to the desktop, session 3, and I'm going to run a little web server so I can see my code in the browser. And come here and open up a console. Okay. By the way, I haven't programmed this before. I did read an article, an online article about linear regression and look up the formula. But that's, I don't really know what I'm doing here. So just be aware, you're tuning into someone who's giving you a tutorial about stuff that he just looked at earlier this afternoon. This is how I do it. Okay. So I think we're ready. This is definitely going to require some serious whiteboard time. It's whiteboard time. That work? No. Here we go. Okay. So I'm just testing this out over here. You can still see and hear me. I am talking to you, the people of the internet. Welcome. And so now let me think about this. On the one hand, so what I'm going to do is use a statistical approach to calculate a linear regression for a two-dimensional data set. And the reason I'm doing this is to just look at the idea of how what is machine learning? It's sort of matching inputs to outputs and then making a prediction based on existing data. So I'm really sort of setting the context. And if we look at linear regression, which is just in this sort of simple 2D space, it'll give us a sort of framework for discussing systems with models with many parameters. And ultimately, even though we can do linear regression with a statistical approach, we could also do it with something called gradient descent. So here are the videos. What is linear regression and ordinary least squares? And what is the math for it? Then make a simple code example that does that. Making a list here. Should I make this list? What is linear regression? What is linear regression? And then we're also going to talk about ordinary least squares method. Then I also want to talk about model checking and other methods. Then we want to look at, boy, is this off the camera? Can the camera see that? It cannot. Wait, I have a way of fixing this. The camera can turn. It's amazing. Then I want to look at polynomial regression. And for this, I think I'm going to use a JS library. And then we're going to get into gradient descent. So I question whether any of this is really necessary or worthwhile. Because in many ways, I don't know. I mean, it's all interesting and learning is good. But it is important to stay hydrated. We do know that. So the question is, because ultimately I could just jump right into looking at a perceptron and I could use gradient descent with a perceptron, but I think this will give us some language and some background and some theory to help us have more of a foundation for when we get into some of the neural network-based machine learning stuff. Do you agree? I think that's the case. So this is my list. It is 4:40 p.m. And I would like to get through all of this by the end of tomorrow. So this week being today and tomorrow, I don't know exactly when I'm going to fit in time to come back to stream live tomorrow, but I'm hoping to. And so I will get through some amount of this today, hopefully at least the sort of first 2, possibly the first 3. Any questions? I'd just like to, so any questions or suggestions or thoughts before I get started? Okay. Yeah. I'm just reading through the chat right now. All right. I'm just seeing. Great. Okay. So I didn't see any questions that I'm going to tackle at this very moment. So I expect that this. So if you haven't watched my live streams before, what happens is I kind of fumble my way through a lot of stuff, and then later it gets edited down to a shorter tutorial video. I expect that these are going to involve quite a bit of editing, because I think I'm going to have to like look stuff up and find things, maybe a diagram, an image, kind of as I go. And I'm happy to take from the chat. The writing on the board is a little smaller than usual. I thought I noticed that as well. Sorry, let me check on that in a second. So I might have to, so if you have suggestions or thoughts, please post them in the chat. If you're a patron and are in the Slack channel, that's a little bit easier for me to follow. So in particular, if there's a good point or question or thought from the YouTube chat, if one of you who's in both could copy that into the Slack chat, that would be great. Okay, let me look at is the writing smaller? Is my handwriting just smaller, or is it actually smaller? I wonder if I zoomed. How is this? Can you read that? A bit too small, I'm seeing from some folks. It's pretty small. It's a little small. Lots of opinions on the size of the writing. Now, I have a feeling that I realize I haven't been in here since, I think one of these is like a Zoom. Look at that. That is too, I feel like that seems too zoomed in. So let me zoom out a little more. Maybe that's a little bit better. Is that just where it was at the beginning? The problem is you guys are 20 seconds behind me. Perfect. Is it out of focus? That's just like the beginning. Write bigger. Oh, what a novel idea. I'm going to just zoom in a little bit. I'm going to try to get a little bit more. There we go. That just makes it a little bit bigger. The question is the focus. How's the focus? Okay, perfect. Great. All right, everybody. So here we go. Focus is fine. Rewrite it a bit big. That list isn't that important. It's just sort of background for me. When I draw and do diagrams and stuff, I will definitely make it bigger. Okay, here we go. I don't know what I'm going to do. By the way, does anybody, so at some point, if anybody has a really good suggestion for a data set that I might use, I think what I'm going to actually do is just make random points and do a regression of random points, or I'm going to let the user click and sort of add points and then fit the line to whatever. If none of this makes any sense to you, hopefully my explanation will make it make sense to you. But if anybody has an idea for a really, the typical things that people do are like doing a linear regression for height value, predicting a weight value based on height, or predicting a height based on hand size, or price of a house based on number of bedrooms, something like that that is a very simple 2D relationship. Okay. This is the invisible laptop. You can see where it is if I stand behind it. Okay, something on Kaggle, yeah, exchange, yeah. But you know, mostly what I would like is to do a very generic tutorial and have people find their own data and work with it. So maybe that's what's better anyway. Okay, here we go. Let's get started. Okay. Hello, welcome to another video in my series on machine learning. Ooh, I don't know why I said that way, but that's very ominous. Anyway, I'm going to talk about something called linear regression in this video. And so in this video, I'm really just going to talk about what linear regression is and why it's something related to the topic of machine learning. Now, if you've been watching these videos in sequence, you might have just watched some videos. You might remember me from such other videos as nearest neighbor similarity score. And so the idea being that we're looking to create a machine learning system, right? There's some kind of quote unquote machine learning recipe, and we have some type of input data that goes into the machine learning recipe, and out the other side comes some sort of output. So this can be any number of things. You know, the classic scenario example is, you know, inputs are can I just start this video? It's been a while. It's been a while since I've been here, and I don't know, I feel like off my game a little bit, and I think that I'm recapping too much because it's been so long since I recorded these videos. But if somebody were actually coming to this to experience it like a course, they would have really, they could have just watched this in sequence maybe a day or two ago or even a week ago as opposed to like 3 weeks ago. So I'm going to, I'm getting some great suggestions for data sets in the chat. Temperature versus ice cream sales, I like that. Galton's original height data is a classic. And is that, Kay Wiekman, who posted that in the Slack channel, is that where the term, is that the same, I think it's Galton, French, where the term regression actually came from? Anyway, so just give me one mulligan for today, and I'm going to start over now. It's very warm in here. Got to get this air situation worked out. Okay, here we go. Okay, hand-eye coordination, brain coordination, not so good. Hand-eye coordination is still seems to work for me. Hello, welcome to another video in my machine learning or my artificial intelligence or something like that series. I'm trying to figure all this stuff out. Okay, so in this video, I'm going to introduce the idea of linear regression. What is linear regression? And why is it something that's kind of relevant in terms of this sequence? So the, we're kind of on this train. Oh, look, train metaphor. We're on this train along the tracks, trucking along, getting towards this idea of looking at neural network-based machine learning systems. And so one of the things we need to do is start building up our vocabulary and our sort of sense of how pieces of, how machine learning works. Please bang my head against the wall for just a minute. Okay, so how does a machine learning system work? The idea here is that we have some kind of machine learning recipe. We have some kind of inputs. And those inputs, it's like a spreadsheet, goes into the machine learning recipe. It does some stuff to it, and it comes out with some sort of output. So output and input. So this is the idea. We looked at nearest neighbor classification and regression. I talked a bit about what classification is, what regression is. Here is a time where I want to look at a particular recipe, a machine learning recipe called linear regression. Linear regression is a useful technique when there is a linear relationship between the input data and the output data. What is a linear relationship? Okay, the idea here is that if we take some data set and we graph it. This known as kind of like known as a scatter plot. We graph it. This is the x-axis, this being the y-axis. So maybe we look at something as was just suggested to me in the live chat that's going on right now, that the x-axis represents temperature, the y-axis represents ice cream sales. Now, I would like to also include sorbet in here. I don't know why I put sorbet in quotes, but the dairy, it doesn't agree with me so much. So, but that's an aside. That's not relevant. Or maybe, oh my goodness, I'm not even in the frame. Help me. I am off screen. The uneven sleeves are bothering people. Yeah, that's really a problem. See, nobody can see the board. All right. See, okay, hold on. Let me try this one more time. Okay. All right. You guys are all very kind to watch. I used to not do these live, and when I didn't do them live, I never actually got anything done because I just stopped and started over and over and over again. You can see why I do that, because my sort of neuroticness leads me to do that. I'm going to have to make the same sorbet joke. I'm just letting you know that was not planned. That was spontaneous. But now it won't be spontaneous anymore. But I think it was a good one. It's a keeper. I mean, maybe I'm doing it the second time. It's very hard with no actual live audience to feed off of. I got to zoom out so I have a little more space. I'm saving Mathieu from editing by just starting over. Okay, so, all right. So this is going to be my last attempt. I'm not allowed to start over again. I'm doing it this time. It is only getting hotter in here. Maybe I need to take off the hoodie, but I thought, I did get the, some people had complained when these weren't even, and I can totally understand that if they're not even. Now the sleeves also need to make sure they're both rolled up. I think subscribers over time, I think that's going down. Okay, here we go, everybody. I need some. Welcome. Oh, this is good. I'm going to leave this in the background. Okay. Hello, welcome to another video in my machine learning series. And in this video, I am going to talk about something called linear regression. So I'm just actually going to move straight over to the whiteboard. I'm going to just move along here. So why are we talking about linear regression? So what I'm leading towards, and what I'm going to get to if you keep watching these videos, they don't exist yet, but I'm going to keep making them, so eventually you might keep watching them, is I'm going to get to neural networks. And neural networks are useful and powerful in the case of large data sets with many, many variables, many, many inputs, parameters that we almost can't figure out mathematically how to make sense of it. Maybe a neural network can do that in some almost magical way. We're going to get into all the details of that. But there are machine learning scenarios where we can actually just calculate precisely using a statistical method the relationship between inputs and outputs, right? So if we were to review, we have this idea of a machine learning recipe. Previously, I looked at k nearest neighbor as a possible algorithm to make sense of input data and predict some sort of output, whether it's classifying or predicting a price, that type of thing. So we have some sort of input, we get some sort of output. So let's take a very simple scenario. Pause, edit point. By the way, this is going so much better so far, but this marker kind of is terrible. So let's try to find a better marker. Just going to see here. Should have gotten some new ones. How's this one? I'm just drawing over here. Oh, you can actually see these. Let's try this one. This is like a sort of fresh one. So let's see. I made it, by the way, really, really small now. Mark on the board where I go out of frame if you passed it. That's a good, so let me, I'm in the frame, I'm in the frame. So I shouldn't, this is out of the frame. So if I'm standing here, I can actually see myself on a monitor there. Okay. So let's take the simplest scenario of inputs related to outputs. And a simple scenario for this would be something like a two-dimensional data set. Okay, so we could graph using something called a scatter plot, a data set. And we're going to make the data set, bear with me here, a temperature. The x-axis I want to think of as temperature. So maybe, I'm really sorry, I'm going to do this in Fahrenheit. I will just have to apologize for that. I'll happily say maths, though, anytime you want. 0 degrees to 100 degrees. I guess it could be negative, so in Fahrenheit. And then the y-axis will be ice cream sales. And this was suggested in the chat. But I'm going to add to this sorbet in quotes for no reason. I'm out of the frame. I'm back. Okay. But you can see this, right? Yes, sorbet. Just not if I put my head in front of it. Okay. So yeah, just because dairy doesn't really agree with me, just in case you were wondering. Okay. So I like sorbet. Okay. So we could say like, oh, when it's 24 degrees. There are only 3 ice creams are sold per day, and then on another day it was 90 degrees, and there were 18, and on another day that was 90 degrees, there were this many, and then you could imagine if you were the owner, the purveyor of an ice cream shoppy, that you could keep track of your sales as it relates to temperature. And then what you could do is that you have all this data. Now somebody comes into your place of business and says, okay, tomorrow the weather's going to be 50 degrees. What could you make a guess as to how many ice creams you're going to sell? And so we could look and say, here's 50 degrees. Well, there was some other day where I sold this much when it's 50, some other day. How could we make a prediction? Well, this is a scenario where it appears there is a linear relationship between temperature and sales. The higher the temperature, the more the sales. The lower the temperature, the less. The fewer the sales. So the idea of a linear regression is to figure out how can we best fit a line to this data. And I could look at this and, hold on, I'm going to be back in a second for some magic. So I'm looking at Kelvin. Okay. I'm back. By the way, this is like a historic moment. Not really, because that'd be ridiculous. This is the first time I'm ever using a marker with a different color on my YouTube channel. Maybe suddenly I'll just get so many subscribers because they'll be like, I heard there's this channel with tutorials and a whiteboard where they use multiple colors. Okay, so we could make a guess, and I could say like, look, that looks like a line that kind of fits the data. That's me just as a human being kind of eyeballing it. So now if I wanted to say, when the temperature is 95 degrees, I could just look at 95 degrees, find this, and find the corresponding, 200 ice creams or whatever sold. So this is the idea of linear regression. Looking at a data set and fitting a line to that data set. Now, how do you do this? There are many different methods. And I'm going to look at multiple methods in different videos. In this video, I would like to discuss the method called ordinary least squares. I'm going to go over here. I'm going to write this down. Ordinary, oh boy, I got a little dizzy. Everything's going to be okay. Least squares. What does that mean? Okay, so if we look at this line, we can compare this is the line that we've fit to the data, as a human being eyeballing it. One thing that I can do is I can say, look, how different is each one of these data points from the line? And I could see, I could essentially look at its distance from the line. And the idea of ordinary least squares is the least squares method is we want to find the line that minimizes all of these distances. So what if we, okay, so if we could think of all of these as data points like, x0, x1, x2, x3, x4, right? We could think of all of these distances as like d0, d1, d2, d3, d4. So if we took all of these distances and squared them, d0 squared plus d1 squared plus d2 squared, et cetera, and added them all up together, that's the sum of all the squares of all the differences. We want to minimize this value. So how do we calculate how do we find a line that minimizes all of those? So you might be asking, well, first of all, why are you squaring the values? Well, this is a common technique. You'll notice that some points are below the line and some points are above the line. So the difference could be positive or negative. Squaring it gets rid of that difference. Okay, so how do we do this? Like I said, there are a variety of methods. And what I'm going to do is I'm going to show you a formula for this, which I have written down. It's another historic moment. I prepared for today's video. This was my preparation. I wrote down the formula. I could pretend that I memorized it by editing this out. If this is still in this video, then I did not pretend. Okay, so let's look at, so first of all, how do we represent mathematically this pinkish, reddish line? So the formula for a line is typically written as y equals mx plus b. I will point out, however, that if you look in the statistics textbook, you might see something like y equals b0 plus b1 times x. This is the same exact formula. M refers to our b1 here as the slope, and b0 or b here is the quote-unquote y-intercept, which is the value where the line intersects the y-axis. So the slope, this m value determines like which way does the line point, and then the y-intercept is how high or low, where is that line relative to the x-axis. So all we need to do is we need to both calculate m and b. So here's the thing. This is while we're looking at this, most data sets that you might work with aren't just simple 2D data sets. There might be, there's temperature, there's, population of the city that the store is in. Maybe, there's the hours that it's open. I don't know. You could think of like all sorts of other data inputs that might relate to the sale of ice cream. And this can actually be generalized much, this could be y equals b0 plus b1 times x1 plus b2 times x2. So there could actually be multiple this is referred to as multiple linear regression. And generally, the same math that I'm going to show you applies to this scenario, but it typically involves matrix-based calculations. Maybe I'll do that in a different video. But it's simpler to look at in just this context with just one input. But we can extrapolate that. And you can think about it as instead of, instead of a line, fitting this to a plane, right? If you had this as, if there was just simply two input pieces of data. Okay. How are we doing so far? You still here? Okay, so now, let's look at this formula. Look, you can see I wrote it down on this piece of paper. Maybe I can auction this off on eBay, or nobody will want this. Okay, I'm going to need that piece of paper. Okay, so here's how we calculate m, the slope. We calculate it as the sum. So I'm going to use this Greek letter sigma. It looks like an E, but it's not an E. It's a sigma, which means sum of x minus x with a line over it, and I'll talk about what that means, times y minus y with a line over it. You could call that y bar, I suppose. divided by the sum of x minus x with a bar squared. Okay, so let's think about what this means. So first of all, x bar or y bar, this means the mean or the average. So what this really is it's all of the x values added up together divided by how many there are. So you could think of x bar as being the sum, and sigma, by the way, means sum. So I'm going to kind of unpack that a little bit. But the sum of every single x, so x index I, so x0, x1, x2, where I goes from 0 to n being the total. So this is kind of mathematical notation to say, add up all the x. You can think of it as an array, right? An array of data points, add them all up, and then divide it by the total number there is, divided by n. So this is really what x bar is. It's just the average of all the x's. Y bar is the average of all the y's. So this means get the average and then take each x minus the average times each y minus the average. And so this really is also, this sigma should really also have I goes from 0 to n, and this is x index I, this is y index I. We have this from 0 to n, this is x index I as well. So you can almost, I'm not going to derive or prove this formula in this video. Maybe I can provide a resource to a page or a tutorial that does that in this video's description. But you can almost kind of intuitively kind of understand, why is this the slope of the line? Because what we're looking at is the sum of all the differences between the average x and the current h multiplied by the average, the differences between all the y's and the average y's. If we add all that stuff up together, divided by all of those x differences squared, you can kind of intuitively understand why that's going to be, if all those values are equal, we're just going to get the value 1, right? So I have to pause for a second because I lost my train of thought. I'm going to, I'm just looking at the chat to see if I missed anything. Okay. I'm looking at the chat to see what people are writing because, hold on, why is this opening here? Because I want to see what I'm missing here. Ice cream sales, I should use all the colors of the rainbow. Are ordinary least squares related to the least squares regression? This is from Alex. Plotting from linear algebra. It's basically the same. The ordinary distinguishes it from weighted least squares, yes. Okay, how am I doing so far? All right, so and I didn't make any horrific mistakes just yet. I got off on a little bit of a tangent there for a second because I was trying to explain why, I was trying to explain this as like having an intuitive understanding of why this formula works. And my explanation, I think, didn't really hold up. So maybe I want to go back and try to say that again, but I want to think it through, and maybe if anybody in Slack has a good thought for me. So again, let's think about, let me talk this through for a second, and maybe I'll explain it again. Think about if we had the scenario where x was equal to y. So the slope would be 1, right? If x is equal to y. The intercept could be 0, but the intercept is not relevant right now. So if x is equal to y, the slope could be 1 because, I'm looking in the chat to see for somebody to save me. If we had all the numbers, we took the average. That makes sense, right? Because the average would be, let's create a scenario where we have just these points. So the average x would be right here, and the average y would also be right here. Right, this makes sense Because if x and y are kind of have an equal relationship, this times this, okay, this times this would be the equivalent of this squared. That makes sense. Okay, so maybe I can come back to talk about, and if y is growing faster as x, it would point up this way. If it's not growing, it would point this way. Because if y is, so this is kind of solidifying in my head. Okay, the numerator is basically the correlation. Thank you, K. Weekman. That is a much nicer way of putting it. Okay, the slope basically defines, Harsh Gupta says, the slope basically defines how much y changes with respect to x. Okay, great, thanks. There's all these wonderful comments in the chat. I really appreciate it. You guys know way more about this stuff than I do. I should really stick with my like generative fractal tree rainbow colored stuff, right? Don't you think? I'm trying my best here. Okay, so let me come back here and say, so I'm not going to derive or prove this formula in this video, although if I can find some supplemental information, I'll link to it in this video's description, or maybe in the comments you can offer a suggestion. But you can kind of get an intuitive kind of sense of why this formula works. So first of all, imagine if x equals y. If the formula for the line were just y equals x, that would mean the slope would be 1. Right? The slope would be 1 if y equals x. Well, look at this. If y equals x, then x minus x bar times x minus x bar would be like that squared. So you could see how m would equal 1 if y equals x. And then you could sort of say the numerator is essentially the correlation. Thank you to Kay Weekbot in the chat for typing it out like that, because I think that's a good way of thinking about it. You can see that, if y is y growing more as x grows, or is y growing less as x grows? You can sort of see how this relationship is going to, between the numerator and the denominator, is going to give you a fraction that describes the slope of this line. So think about that. Hopefully it has some intuitive sense, and I'm sure people in the comments will write some nice explanations that help with that understanding. So this is really it. So what I want to do now, I'm going to do this in the next video, is I want to program this. So I think what I'll do is I'll program it in such a way where a user can click and add data points, and each time the user clicks, I will implement this formula and draw the line of best fit according to the ordinary least squares method in Canvas in the browser. And after we do that, I will talk about, well, what are some reasons why linear regression might not make sense for your data. But this is the idea. This is just to kind of recap for a second. The reason we're doing this is a model, right? The idea of a model is you try to fit it to the data. We have known data, training data, temperature with actual sales. We want to fit our model. Our model just has 2 parameters, the slope of the line and the y-intercept. And once we solve for those parameters, we can make new predictions. And even though it's kind of overly simplistic here, this is the exact same process that I'll employ again and again. Once we look at a simple perceptron, then a multi-layered perceptron, and then things like convolutional networks or recurrent networks, all this is laying the foundation for more sophisticated, robust machine learning-based systems. Okay, so I hope this was helpful and made sense. If it, okay, Okay, so I hope this was helpful and made some sense to you, and you have an idea of what linear regression is, what the least squares method is, and if you're inclined to continue, just keep following to the next video, and I will program this particular algorithm from scratch. Okay, thanks very much. See you there, maybe. Okay, how are we doing? exponential, classic example, exponential ratio to the log plots. Yeah. Okay. Okay, so how did we do, everybody? I wonder how long that'll be. That was probably like 15 minutes or something. So now what I'm going to do, so if Mathieu, if you're there, what I think I'm going to do is not have this be a coding challenge. I don't know why. Let me go look at the playlist here. I mean, that certainly was just an explanation. I could make the second thing like a coding challenge, but then it wouldn't have the explanation with it. I wonder if I look at my playlists, where I'm thinking this would go is just as part of session 2. No, are we in session 2? No, we're in session 3. Do I have a session 3 one yet? Maybe I don't have a session 3 one just yet. Did I do an introduction to session 3? I thought I did. Yeah, I did. So maybe I just didn't make that playlist. So I think this can just go in, where are we here? Introduction, session 3, what is machine learning? And then it goes after these. I kind of am so arbitrary about whether, oh, I need to speak about how to find B. I forgot about that because that's such an easy part. Oops, I got to go back. We'll just splice this together in a weird out of order way. Hold on, I mean, B is sort of obvious once you have, yeah, thank you. I don't know why I forgot that. Okay. I'm looking at the chat. Okay. All right. Oops. I forgot. So for the formula of a line, y equals mx plus b, the slope is the more complex calculation, actually. Once we have that slope, it's pretty easy to calculate the y-intercept. Where is b? And the formula for that is b equals m times x bar plus y bar. Did I get that right? Oh, no. I totally did not get that right. What am I saying? Let's just edit this back to where I get it correctly. The formula is b equals y bar minus m times x bar. And you could kind of see why this is the case, right? Because remember, y equals mx plus b. So all I need to do is say b equals y minus mx, right? And we could just use the average of all the x and all the y to figure out where should that line be shifted. So this is the formula to calculate that y-intercept. So we can do this with a statistical method. We run through all the data. We calculate the slope, we calculate the y-intercept, and we have that line, that formula for the line for which you can make predictions for new data. I hope you found this, blah, blah, blah. So now we can go back to that blah, blah, blah. Oh, okay, wait. What else did I miss? It's so nice. It's really good that I have a live chat going because I clearly make so many mistakes. Also, your sum should run from 1, not 0. Oh. Yes, that's a good point. I'm right, or it would be 0 to n minus 1 technically, I guess, if I'm using sort of array indexing. So maybe I'll addendum this. Okay. Good luck, Mathieu, editing this together. Okay, this could come still before my finishing point. One more thing, as it was pointed out in the chat to me, thank you to Kay Weekman, yes, again, which is that, who should really be just making these video tutorials because I just keep getting everything wrong. But I'm so used to counting from 0 in the array index programming world that I live in. There's 5 elements, 0, 1, 2, 3, 4. But in this case, in this notation, this should really be sum from I equals 1 all the way to n. There's 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could think of them as 0 to 9, 1 to 10, whatever. It's the same idea, but technically speaking, I think my formulas are a bit off if this doesn't say I equals 1. So that's a good correction. Thank you very much. Now I hope blah, blah, blah. So this could be, or I could divide by n plus 1 as the average. No. I think my fixing explanation there was good. Okay. Okay. I don't know why this Muzak stuff gives me such happiness. No, I did forget the format for the y-intercept, but then I got it in it. Okay. Did I miss anything else? Because now we can program it. What time is it? 5:20. Okay, I'm not seeing any major corrections. So we're going to program it now. Hello! Welcome to another video, which is part 2 of my linear regression tutorial. And in this video, I'm going to take this beautiful blank canvas that is the web browser and make linear regression happen in it. Is that a weird thing to say or do? Hopefully not. Anyway, so how are we going to do this? So first thing that I need is I need to, boy, this is always more complicated than you think. I'm like, oh, it's going to be so simple. One thing that I should do, I should probably, hold on. Do I need to map the screen? Work with me, folks, here. Do I need to map the pixel space to a more kind of traditional Cartesian plane, like where 0, 0 is in the bottom left, and kind of normalize it between 0 and 1? And so I get a kind of less insane looking formula for the line? Or should I just live with the coordinate system the way it is? It's probably useful to map it because when you get data, it's not going to have the pixel-based stuff. Okay, I think I'm going to have to map it. Okay. Okay, I did some thinking there for a second. And wait, I'm going to do a little more thinking. Can you see the wheels turning? Because actually I was just kind of Homer Simpsoning it there. Like I was thinking about, what I was going to eat for dinner. Okay, so here's the thing that happens a lot in machine learning and computer graphics. This thing that I've drawn over here is sort of as an arbitrary scale. There's a temperature, which I botched by doing it in Fahrenheit, which is like the worst measuring system ever. Oh, I don't want to be insulting. It's just, and Fahrenheit, you're wonderful too. You have many good qualities, just like Celsius. I love all my temperature systems equally. Anyway, but let's say I wanted to actually graph this data. What do I have? I have a canvas that I'm going to draw in the web browser, which has like 0 to 600 pixels and 0 to 400 pixels. 0, 0 is in the top left. It points down. It points to the right. I think I need to map my pixel space. So what I mean by that is I want to have my pixel space represent 0, 0 being in the bottom left, and I want the x-axis to be kind of go from 0 to 1, and the y-axis go from 0 to 1. So I need to have kind of a scale, a data scale, and then the computer graphics scale. And I'm sort of making this up so it can be anything, but when you go and apply this with real data, you need some way of mapping from your data to pixels if you want to graph it. In a lot of systems for doing data visualization, if you're using R or D3, or some Python graphic stuff, it's not going to do this for you automatically. But we're in JavaScript land. We're going to use P5. We're going to do the maths ourselves. Okay. Okay. So I'm going to first of all I'm going to make a canvas, and I'm going to make a canvas that's 400 by 400, and I'm going to draw the background with a gray value of 51. Okay, whoa, that's a giant canvas. Okay, that's better. So I'm going to make it a square just to make things simpler right now. And then what I'm going to do is I'm going to say mouse pressed. And whenever I press the mouse, I'm going to create a new data point. So I'm going to say x equals map mouse x, which goes between 0 and width, to a value between 0 and 1. So this is me mapping the x values between 0 and width to 0 and 1. Because the pretend data, if this were real data, I'd want to know what the actual range was. I wouldn't be getting it from a mouse click. And I'm going to say var y equals map mouse y from 0 to height. Now, however, I'm going to say from 1 to 0. Because I want to have the bottom of the window be 0, right? If I come over here, this is 0, 0 right over here. So that's height, which is 0. 0 is 1. Okay. So then what I'm going to do is I'm going to say var data equals create. I'm going to use the p5 vector object just to store both of these things. And I'm going to say point. Call this a point. And I'm going to make an array called data. And I am going to say data.pushPoint. So what I've done here is every time I click, I create a data point based on where the mouse is. So what do I want to do in the draw function? You know, it's a little unnecessary to have an animation loop here because I could potentially only redraw, but whenever I have a new piece of data, what I'm going to do here is I'm going to iterate over all of the data. So var I equals 0, I is less than data.length, I plus plus. And now what I need to do is do the reverse mapping. So when I put the data into that array, I want to map it to the appropriate range, and when I get it out, I need to map it back to the pixel range. So I'm going to say var x equals map data index I dot x, which has a range between 0 and 1 to between 0 and width. And I'm going to do the same thing for y. Map data dot y, which has a range between 0 and 1, and map that to a range from height down to 0. If you haven't seen this map function before, I have a whole video just on what is map. So you could go, I'll link to that in the description as well. Then I'm going to draw an ellipse at x comma y. That's 8 pixels by 8 pixels. I'm going to say fill 255 and stroke 255. And now what we should see here is just the visuals that I want, which is wherever I click, I get a point. So this would be a lot simpler without that mapping, but the mapping is going to be useful for us as we start to try to compute the formula for the line with the least squares criteria. Okay, how are we doing so far? I think we're doing okay. I mean, I feel okay. It's probably going to edit it out. Okay. All right, so what's the next thing that I need to do? Oh, we need to calculate m and b. So when should we do that? So let's make a global variable, m. Let's call it, I think I could call it m, equals 0, and var b equals 0. And let's actually make m equal 1. So let's see, if we have an m and a b, right, the formula for a line is y. Okay, so let's what are we going to do? Okay, I got it. Okay, so here's the thing. I want to draw that line. So how am I going to do that? Well, I could just take the x value here and then the x value at the end, calculate the corresponding y values for both of those points, and then draw a line between them. So let's do that. So let's write a function called drawLine. And what I'm going to do is I'm going to say var x min equals 0, var x max equals 1. Then I'm going to say y min equals m times x min plus b. And y max, you know what, this is really just like x1, x2, y1, y2. Like I'm really trying to get 2 points, x1, y1, and x2, y2. So in fact, this would make more sense to write it this way. y1 equals m times x1 plus b. And y2 equals m times x2 plus b. And now all I need to do is say stroke 255. Oh, I could make it a different color, just like I had 2 different color markers. And I could say line x1, y1, x2, y2. Only I can't, right? What's the problem? I calculated this line with my units, my scale, my mapping of the data of having this range between 0 and 1. And so I need to unmap it to the pixel stuff. So this is a little bit awkward, but let's just do it this way. Let's say x1 equals map x1, which has a range between 0 and 1, to between 0 and width. And by the way, I could just multiply it by width. but I'm keeping the map function in here because you might have a very different scale. Y1 is the same thing, but go from height down to 0. And then we're going to do the same thing for x2 and y2. Are you asleep yet? And now we're going to draw, so we're going to calculate those values, map them to pixels, and then draw the line. And so let's, in the draw function, let's have draw a line. So now, oops, I have an error, line 50. Oops, I guess I have an extra bracket somehow. Oops, y2 is not defined at draw a line. What did I mess up here? Oops, this should be y2. Thank you very much. There. So you can see there's the line. So, I mean, that's what the line is always going to be. So now I know that if I have the m and the b for the formula for a line, I can visually represent that line. Now all I need to do is use this formula here to calculate m and b based on the actual x and y values. Let's do that. Okay, so let's remind ourselves. So let's write a function and let's call it linear regression. Oh, and I wanted to talk about where the term regression comes from. It's this French thing, and it's regression to the mean. You can look it up. Okay, so what are we going to do? Well, one thing we know we definitely need to know. Time out. I forgot to mention in the beginning of this video. I forgot to mention in this. I forgot to mention in this video that the beginning that you should watch the previous one. How can I correct that? We'll splice something in there. Somebody remind me at the end. I'll record me saying that for a sentence, and Mathieu will splice that in there. Okay. Okay, so if we look at the formula, and this, I went through all of this from the previous, in the previous video, where I talked about this formula. Something that I really need is x bar and y bar. And x bar is the mean, or the average of all the x values, and y bar is the mean of all the y values. So adding them all up together, dividing by the total number. So I might as well add those up. I mean, calculate those first. So the first thing I want to do is say x sum equals 0. And we're going to go through all of the data. We're going to iterate over all of the data. Y sum equals 0. We're going to say x sum plus equals data index I dot x. Y sum plus equals data index. So we're adding up all of the x values and all of the y values. And then we're going to say x mean equals x sum divided by data.length. And the same thing for the y mean. So this is the average. So we now have the average of all the x values and the average of all the y values. Now what we need to do is we need to calculate the numerator and the denominator. Let's do the numerator first. So the numerator is, so first I need to, I'm going to have to sum up some stuff here. So first I definitely need to loop through all the data. Boy, we've been doing a lot of looping through all the data. So I'm going to say numerator equals 0. So the numerator is going to add up all together each data points x minus x mean times each data points. And you know what I'm going to do? I'm going to just use some extra variables here, which I think will make things a little cleaner. Just so we can look at the formula. This is now the numerator. Right? This is in code right here, exactly what's written in the formula here. It's adding up all of the x's minus the average of x's and all the y's minus the average of y's multiplied together. Okay, so we've got that. And now all we need to do is we might as well do the denominator at the same time. Why not, right? Denominator, can I say den for that? We're going to add up, the denominator is x minus x mean times x minus x mean. It's just that added up squared. And then m equals numerator divided by denominator. Whoops, denominator. So let's think about this. Could we have an issue where the denominator is 0? You know, it's going to happen. We should protect against it. If all the x values were the same, then the average would be that value, and then the difference between all the values and the average would be 0. But let's not worry about that too much right now. Did I get numerator and denominator mixed up? Okay, time out. No, I just spelled it wrong, right? Okay. Edit that part out. Okay, now once we've done that, we can now say b equals y mean minus m times x mean, right? Is that right? b equals y mean minus m times x mean, which we get because y equals mx plus b. So now that we have that, we've got everything. So I should be able to, we're going to have a problem. Oh, this is actually going to happen instantly. So this is only worth doing if there's more than one data point. So I think we should say here whereas in draw, we're going to say if data.length is greater than 1, then calculate the linear regression and draw the line. All right, let's give this a try. Hey, look at that! That was amazing. Nothing ever works in the first try. So this kind of makes sense, right? You can see I can add a bunch of points, and it's always fitting that line to the points. This is linear regression, interactive linear regression in the browser. It's probably not anything anybody should be too excited about, but it's making me happy right now. Time out for a second. What's known as perfect collinearity? The problem with when you guys write useful pieces of information in the chat is I see them like 30 seconds or a minute later because I'm in the future, and I don't know what relates to what. There's more that I need to talk about in this video. I just want to take a break for a second. If all the x values are 0, then m equals 0, yeah. Okay. So now what I want to talk about is model checking. This is really this is a really useful. K. Weekman also pointed this out to me. So okay. So which I want to talk about here. When all the x's are equal, that's perfect collinearity. Perfect collinearity. Yeah. All right. Boy, all this stuff. Ooh, look at this. You guys should be watching this YouTube video. I'm sure it's much better than anything I could possibly ever make. Ooh, what is an example of perfect multi-collinearity? Okay, maybe I shouldn't read Stack Overflow during my live stream. Okay, so the thing that I want to talk about now, and I'm going to bring up weekman.github.io ml. What's the URL for K. Weekman? What's the URL for your sandbox? Maybe it is? Yes, linear regression. Great. So I think I'm going to just use this as a demonstration, if you don't mind. I will, of course, credit you and put a link to it in the video description. But yeah. Okay. All right. Okay. So somehow I need to get back. So I need to get back in to this video tutorial talking about, does linear regression actually make sense? and then and look at, talk about model checking. And the term, the sort of residual plot is useful. And then look at Anscombe's quartet and just kind of like finish up and give some people some ideas of things you could try. And then I need to remember to splice something in where I say something about watching the previous video. Sorry, here's the, Mathieu is asking for, this is, if anyone can't find, this is the URL. Someone wants to post this in the chat. Okay, people are still talking about temperature. I can't wait for the YouTube comments on my Fahrenheit versus Celsius. Kelvin, maybe I should just do everything in Kelvin. Is there like an Esperanto, equivalent of Esperanto? I guess maybe, okay, let me get out of this right now. Okay. Okay, so this video is really complete. We see that I have this linear regression that's calculated. Now, here's the thing. What can you do with this? So first of all, you might think of some more interesting interactive ways of playing with the data, whether it's being able to click and move these points around, drag and drop, randomize all the points. I'm sure you could come up with some more interactive possibilities. But one thing that I think is really important to talk about is whether it actually makes sense to use linear regression, a linear regression model for your data. And one way, that, there's lots of reasons why this could be, why you might not want to. First of all, simple, do I dare erase this? I can just come over here. Simple way to sort of talk about this is, what if this is a plot of my data? Well, you can see I could apply a linear regression to this, and I'm going to get a line that maybe looks something like this. Forgot my multicolored marker, and I'm off. Let me try that again. I'm off. I said no more mulligans, but I'm going to give myself a mulligan here. Except I can't fake erase it. Continuity error. I'm going to put it back. What's the chance? Oh, it's got all the, ugh. I'm trying to recreate my drawing, which is kind of sad for a variety of reasons. Someone's going to notice this. Oh yeah, and it was like D. I forgot that I had like X0, X1. Boy, I'm too far gone now. I have to continue this. D0, this should be like X1, D1, whatever. Okay, D2. Okay, close enough. No one will notice because I'm going to walk over and erase it momentarily. Okay, let's try this again. Okay, so let's think about a scenario where you wouldn't, where you wouldn't want to use linear regression. So what if your data happened to kind of look like this? So I could fit this, I'm trying to get better at the multicolor. I could fit this with a line, and I might still get even like the same sort of line. But actually, if we really looked at this data, I could see that, you know what? This data, I could fit a curve to this data. I could fit something like y equals mx squared plus b, or even plus, m0 x squared plus m1 times x plus b. And I'm probably using the wrong, I should start using, this is b0, b1, b2, right? So I could essentially create a polynomial formula, a formula that has not just x, but x squared and maybe x cubed or x to the fourth power. And I'm actually going to look at that in a future video. So I will do a video where I do polynomial regression, but I'm just going to use a JavaScript library that has it built into it, so just to sort of demonstrate the idea. But this is something that I might want to do. And what's interesting about linear regression, and this has been demonstrated, there's a famous data set, Anscombe, anybody know how to pronounce that? There's a well-known famous data set called Anscombe's quartet, where I'm going to look at these four graphs. Each one of these has the same exact linear regression line, right? You can see that with this data, the line is the same. But does this line really make sense? Well, for this one, it kind of does, right? You can see that it's a nice approximation of the data. With this one, it does, but you can see it's kind of off because there's just an anomaly. And maybe we should build something into our model to account for that anomaly. Or this one over here, even though linear regression has that same line, it's actually, you could figure out that we could use a polynomial function to estimate that. And here we got some kind of like crazy nonsense where we have all the same x values. So this is an important thing to realize, that linear regression is not some kind of magic. It's not a recipe for all data, for all inputs and outputs, but it is a simple model that will work for a lot of data that is linear. One way to evaluate whether or not the linear model is useful for your data set is to look at something called the residuals. And coding trained viewer extraordinaire K. Weekman, you can go to K. Weekman's GitHub, kweekman.github. I'll include a link to this in the video description, created a much more sophisticated demonstration. This is the same exact idea. I can move these points around. And I can kind of, I can randomize them, and I can see the same linear regression. But what this is showing is a residual plot. The residual plot shows the magnitude of the difference from the line to the data point for each and every data point. And we can actually, that the Anscombe data is built into this. And you can see this makes sense. If you have a kind of random residual plot, that's a good sign. If you have a highly patterned residual plot, then it's most likely that some other model could be useful for your regression. So something you might consider doing as an exercise is researching more about different data sets, trying to implement, I mean, you could find K. Weekman's code on GitHub as well, but try to make your own residual plot from my scatter plot code. And what other types of interactive features for importing or using different data sets? What other colorful and creative ways can you explore visualizing the process of linear regression? Okay, so thanks for watching this video. I'm going to do a couple more videos on this topic. I'm going to look at polynomial regression with a JavaScript library, and then I'm going to use a different technique to calculate a linear regression known as gradient descent. And the main reason I want to do that is gradient descent, as opposed to this least squares methodology I used here, is a fundamental method for neural network-based learning, for a learning method for neural network-based systems. So we're going to do that for linear regression, which will set us up well for neural network stuff later. Okay. What did I miss? I didn't say goodbye yet because I was sure I missed something. How was that, K. Weekman? Did I get at the sort of essence of some of the stuff that you mentioned in the Slack channel earlier today about model checking and the residual plot? I would love any feedback from anybody before I put a bow on this 2-video linear regression thing. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I need to do the previous video. This dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot. I was off camera when I was drawing the polynomial. That was probably fine. Somebody can CGI me back in, right? How hard could that be? Somebody, by the way, said they wanted more green screen footage of me on Twitter the other day. So here we go. I don't know what I'm supposed to do, but I like it when yeah, anyway, okay. There we go. There. Okay, come back here. All right. Indeed, short and clear. Good. You know, this isn't a course on statistics. I don't know what this is, but it's I'm trying to give some background and some basic steps, so hopefully people got the idea here. Okay, so, the whiteboard content. Well, let me look back. Oops. Was there some part over here that was not usable? Oh, because I drew down here? No. I think it was okay, right? So hopefully it's okay. I was getting some messages that there was maybe a missing part, but okay. Somebody said once I start doing, somebody made a YouTube comment that once I start doing ES6, we're gonna have a whole new the super song. Never forget the super. Okay, at the top. Oh, that part is not visible. I see it. Okay. Yeah, the hay. Okay. All right. So what do we've got? I don't know what this is going to do, but so this will get spliced somehow. So I'm just going to say, let's try this. Before I begin coding, I just wanted to mention, if you just jumped into this video, I walk through a full explanation of what linear regression is and the formula that I'm about to use in the previous video. So check this video's description to a link to that previous video. Otherwise, keep watching. I'm going to get started coding. Will that work to splice in? I hope that does. All right, it is 5:50 p.m. So let's review where I got to today. I got through half of this. So tomorrow, I think I'm going to do, now, I hope that I have some time tomorrow. The schedule is a little bit tricky, if I were to live stream tomorrow, it would be somewhere in the 2 to 5 p.m. probably range. I definitely have to be done by 5, and I probably can't start any earlier than 2. So somewhere in that range of time, I'm going to try to live stream, and I will cover these two last pieces. Okay, so I have about 5 to 10 minutes before I have to go. So I will try to see if I can answer a few questions. I know what I need to mention. Shoot, I should have done this at the beginning. Always forget. Well, better late than never. Where am I going to find information about this? Let me go to the Coding Train Reddit. Okay, so there's all sorts of things on here. There's a Coding Train, look, maybe I can find some more questions here. Maybe I'll try to post another, I'm in the wrong screen. There's okay, so somebody set up a Coding Train Discord. And because I'm old and out of it, I have no idea what Discord is. But I wonder if I should get used to it. So I wanted to mention it. I guess it is an unofficial chat talking platform for people who are interested. So you can click, maybe I'll try to join it and look at it. I'm using Slack for the people who support my channel through Patreon. But I'm always interested in other platforms, especially if they're open source and flexible. Not that Slack is, but anyway. So I wanted to mention that Discord server exists. So please join that community if you're interested or find that to be nice and interesting. I'm also trying to figure out a good way to receive questions. So I was trying to make a question thread for each week, which I did 2 weeks ago. What's today? But I didn't make one. Maybe I'll make one for tomorrow. But let's see if there are any new questions on here. I think I answered some of these already. Yeah, I answered most of these already last time. So maybe I'll try to make a new question thread. And okay, but in the chat from G4M3M4NI4C in the Slack channel asks, are you going to do some TensorFlow? Yes. So again, if you want to know what's upcoming this summer, everything is here. So I've actually made all the examples and done quite a few and written up some readmes with supplemental links. I intend to make videos for every single topic that's here and hopefully more. And you can see that when I get to convolutional neural networks and recurrent neural networks, I'm going to use TensorFlow for that. I am, however, using currently in my examples Keras which is a little bit of, which is a layer on top of TensorFlow to make it a bit easier or higher level. So that's what I'm planning to use at the moment. I have no idea what Kotlin is. Is there a thread to submit video ideas? Yes and no. I mean, there is one. I've been using a GitHub repository. Oops. It's under the Coding Train GitHub, Rainbow Topics and Issues. And what I do, you can see people are suggesting, and I think I'm going to do Tetris, by the way. Somebody originally suggested Tetris and was like, and I sort of thought that's kind of impossible. And then I saw Siraj doing something with Tetris on his YouTube channel, and I was thinking, oh, I could do Tetris. So this summer, my plan is to keep some momentum with the machine learning stuff, but I would like to also pepper in just kind of random coding challenges. I want to do the Dragon Curve, people have been suggesting, other games like maybe Tetris. So I might do sort of an every other week type thing. Like I'll do some machine learning stuff, and then next week some just goofy generative art or game stuff, and then come back to machine learning stuff. And I'm also hoping to schedule a whole bunch of guests. I need to get working on that. Okay. Let's see. Any other questions? I'm going to play my goodbye song. Somebody could help find this song on Sound. No, I think I got it off the. Oh, it's very loud. I think I got it off of I think I got it on like Free Music Archive once when I searched for Rainbow and like public domain. Game of Life. Sudoku Solver would be interesting. Game of Life has been requested a lot. I have a bunch of video tutorials on Game of Life that I made sort of in processing back in the day. I guess I could do it again. Maybe that would be a good processing challenge to do, just to program it from scratch and just kind of to do it. I'd be happy to do that. I lowered the audio. Hopefully it's okay. Off the music, yeah. Thank you guys. I don't know why. Something that's really hard about doing these live streams, and I used to feel more comfortable with this, and I think especially when I'm doing this more technical stuff, math-based stuff, that's really almost like I'm supposed to be teaching something real rather than just like coding up something fun. Not that those two things need to be mutually exclusive. I really feel a bit lost into how it's going. So hopefully people found today useful. Oh, you know what I think we should do? It's nighttime for a lot of you. Let's take a little break here for a second. It's been a while since we read. This is probably way too loud. From the Coding Train storybook, 1,000,000 random digits with 100,000 normal deviates. Previously on the Coding Train, 54,392, 7,845. Okay, that was the previously. Now it's the now? I don't know. 75,821, 10,038. Oh, no, that's, yeah. 59,767, 46,323, 61,884, 92,962. It's kind of an interesting random number, 92962. Next week, next time on the Coding Train. Oh, my lullaby. Let's just try this music. Next time on the Coding Train, we're going to read some Gaussian deviates. 0.820, 0.225, 0.925, 1.514, 0.274, 0.131, 1.009, 0.949, 0.336, 0.449, 0.378. I just read one of the numbers. Will anybody ever know? I'm on page 127. Okay. I feel like I could do all this nonsense at the end. Something else that I wanted to read is I thought that I would try to read you guys some quotes from this book. It's called In Her Own Words. Red Burns was the founder of ITP. She was a mentor to me, and she would open every year for all the students, here's a picture of Red, a presentation in her class with, and this book is, actually I'll just read this to you. Most alumni remember the first day of the applications class, Red's class, because of the slides she showed to open the school year. The words are an encapsulation of her philosophy and her hopes for ITP students. They are words to live by, and also words for us to all remember Red. Here she is in her own words. So I thought that periodically I would also read to you some quotes from this book. Maybe I would do one per week. Even though I could just do all of them and they kind of are nice in sequence. I could pick a random one, or I could just read you the first one. Maybe I'll read these in order. So today's quote from Red is, "As you come together, depend on each other." Okay, so that's my word. This episode was brought to you by the letter, the quote. Anyway, so that's one quote. I will come back tomorrow and I will read you another one. And maybe someday somebody could splice all of these things together. Okay, what else do I need today? Let's listen to the This Dot song. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this. I'll see if there's any more questions. This dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget the this dot, this dot. All right, everybody. This dot. Thank you all for watching. This dot song. I hopefully will be back tomorrow. I'm not guaranteeing it at this point, but it is a, oh, this is probably really loud. It is a plan that I hope to have. I will certainly be back next week. Over the summer, you know, I'm kind of, the commitment I've made is to try to do a live stream every week. And, you know, there are periods of time during the year, this summer in particular, where I'm going to be traveling for a week or two. I'm traveling for a week in June, 2 weeks in July, 2 weeks in August. So there will certainly be some weeks where I'm not making videos, but I'm hoping that they're going to be, because it's the summer and I don't have classes at NYU right now, where there'll be some weeks that I live stream twice. And this is a week that I'm hoping to do that. I'm hoping to be back tomorrow, at least for another hour, because I want to get through all of this stuff. So that song ended already? Okay, so thanks for watching. And I will see you guys maybe tomorrow or in a future live stream. I appreciate your support and your kind words and your constructive criticism and feedback always. Enjoy your coding. Also go outside, give somebody a hug and enjoy some nature. Breathe in, smell the flowers. Don't get too close, especially if you're allergic to anything that's like in the flower, you know, that sort of thing. Okay, see you guys. Goodbye. This live stream will be available as an archive soon enough. Okay, goodbye. Oh, that just doesn't turn off till I click this button.